Whenever scientists discover a new exoplanet, they become eager and hopeful. It might show signs of life. It's already known that our galaxy contains many more planets that could potentially support human life. NASA has invested significant time and money in exploring these worlds, and it now appears that their dedication is starting to yield results. One of the most groundbreaking developments came with the release of the first real images from another world, captured by the James Webb Space Telescope. Some of the most exciting discoveries made with this incredible tool are the unexpected ones. To better understand the stars, we've long used instruments that gather more light than the human eye can see, like binoculars. Throughout history, humans have created various tools to uncover the mysteries of space. Although scientific progress has been steady, nothing has come close to the revolutionary achievements of the James Webb Space Telescope. This engineering marvel has done exactly what it was built for. It has allowed us to look back into the earliest moments of the universe. For the first time, we have a sharp and detailed image of the universe's very structure, a milestone that significantly advances our understanding of the cosmos. Webb's gallery includes 18 unique images, each highlighting different capabilities of the telescope. Together, they represent a leap forward in space exploration and in our quest to understand the future of humanity in the universe. Unlike any previous telescope, the James Webb is the largest and most powerful space telescope ever constructed. It is reshaping how we understand the universe. With its state-of-the-art technology, the JWST allows scientists to peer into a time when the universe was only about 200 million years old. This one instrument has essentially given us the ability to rewind cosmic history. Additionally, it captures long-lasting images of the earliest galaxies ever formed, ushering in a new era in the study of space and its origins. The telescope can observe some of the first stars that ever existed, shining brightly in the vastness of space. Even during its planning phase, it was unlike anything conceived before. On December 25, 2021, the James Webb Space Telescope launched aboard a European Ariane 5 rocket from the forests of South America. It was a historic Christmas launch, capping off 3 decades of work by over 10,000 experts from around the world, with a budget exceeding $10 billion. Given the scale of the mission, there was a real risk that something could go wrong during the launch. Fortunately, everything proceeded as planned. The journey lasted about a month and covered nearly 1 million miles, ultimately reaching Lagrange Point 2, L2, where the telescope would remain. This spot in space is not only gravitationally stable, but also lies in the opposite direction of the Sun from Earth. Other observatories, including Hubble and Planck, have also been positioned here, proving that it was an ideal location for Webb's mission. NASA assigned 4 primary scientific goals to the JWST. First, it would observe the universe's first light, a crucial moment in cosmic history. It would also investigate the formation of galaxies in the early universe, explore how stars and protoplanetary systems are created, and study planetary systems, including how life might begin on planets. These topics are essential to space science, but due to previous technical limitations, they haven't been thoroughly explored in recent years. Now, with the capabilities of Webb, there was a need to gather specific, detailed data and consult the brightest minds in astrophysics. Before Webb could begin its scientific observations, it had to pass a series of rigorous engineering and calibration tests. One critical step was the deployment of the sunshield, a 5-layered barrier that protects the telescope's sensitive instruments from the sun's intense heat and light. This shield was folded accordion style for launch and had to be carefully unfurled and aligned, layer by layer. Any misalignment or damage could have rendered the telescope ineffective. Successfully completing this stage marked a crucial milestone. Next came the deployment and testing of the telescope's components. Launching the telescope into space was only part of the task. It also had to operate flawlessly. each of the scientific instruments, including the near-infrared camera, NIRCam, the near-infrared spectrograph, NARSPEC, and the mid-infrared instrument, MIRI, had to be activated and tested individually. These tools each serve a unique function in capturing various wavelengths of light, providing multiple perspectives on cosmic phenomena. These tests confirmed that JWST was fully functional and ready for its mission. Scientists were thrilled, as projects of this complexity rarely proceed without setbacks. The telescope's success in each phase was exceptional. This massive undertaking included contributions from over 300 academic institutions, organizations, and companies across 29 U.S. states and 14 countries, a truly international effort. The telescope's main mirror, made of 18 hexagonal segments, required precise alignment to produce clear images. Preparing the telescope involved multiple complex steps: deploying the sunshield, extending the support structures, and carefully positioning the mirror segments. Each mirror segment was then fine-tuned for scientific precision. If anything went wrong, the loss could exceed 10 billion. Calibration involved targeting known stars and aligning the telescope's tracking systems to ensure accurate observation. By July 2022, after successfully completing all the necessary tests and calibrations, NASA declared JWST fully operational. The 17 modes of the telescope's 4 instruments were verified, and the telescope was officially ready to begin its mission of discovery. Like all telescopes, JWST is designed to gather and focus light. What sets it apart is that it operates entirely in the infrared spectrum, a part of the electromagnetic range that resembles heat rather than visible light. Think of it as an advanced night vision camera capable of detecting faint sources of heat from the farthest corners of the universe. Its enormous 20-foot mirror can collect more light than any previous space telescope, allowing it to observe incredibly distant and faint objects. Positioned beyond Earth's atmosphere, it avoids interference that often affects ground-based observations. Infrared light is especially important in space exploration. Its longer wavelengths allow scientists to detect objects and phenomena that would otherwise be invisible. Because Earth's atmosphere blocks much of the incoming infrared light, a space-based telescope like JWST is essential. Another reason for choosing infrared is related to the expansion of the universe. As galaxies move away, their light shifts toward the red end of the spectrum, eventually entering the infrared range. Observing this red-shifted light allows JWST to essentially look back in time, revealing what the universe looked like in its earliest stages. This isn't just a metaphor, it's how the telescope truly works. Since light takes time to travel across space, the further away something is, the older the light we see. Therefore, when JWST observes distant galaxies, it's seeing them as they appeared billions of years ago. This capability allows scientists to study the early formation of stars and galaxies and better understand the origins of our universe. On July 12, 2022, NASA revealed the first scientific images taken by the JWST during a live broadcast. The images included incredible sights such as the cosmic cliffs of the Carina Nebula and the ethereal Southern Ring Nebula. JWST also analyzed the atmosphere of WASP-96b, a hot gas giant exoplanet, and captured a detailed view of Stephan's Quintet, a group of interacting galaxies. These images were both visually stunning and scientifically valuable. For example, they revealed new insights into how galaxies interact and how exoplanet atmospheres evolve. Just one day earlier, on July 11, 2022, U.S. President Joe Biden, Vice President Kamala Harris, and NASA Administrator Bill Nelson unveiled the deepest infrared image of the universe ever taken. Captured in just 12.5 hours, using one of JWST's instruments, it represented a remarkable achievement. Even before that, in February 2022, JWST had already begun taking images of starlight. One early photo showed a mosaic of 18 bright points, each from a different segment of the telescope's main mirror. These points were from a single star, HD 84406. NASA's Thomas Zurbuchen commented that these points would soon merge into one as alignment improved. A few weeks later, NASA released a refined image of the star, demonstrating how accurately the telescope's optics had been calibrated. During these early tests, the telescope even captured a selfie, using a camera built into its NIRCam instrument, initially designed for orientation. One mirror segment stood out for being properly aligned ahead of the others, but over time, all the segments were synchronized with incredible precision. Once everything was in place, JWST began producing groundbreaking images. One early achievement was an enhanced view of the Eagle Nebula, particularly the iconic Pillars of Creation, towering columns of gas and dust that serve as stellar nurseries. While the Hubble Space Telescope had previously shown the beauty of such structures, it couldn't peer into the hidden processes inside them. JWST, using its advanced infrared imaging, unveiled the active regions within these clouds where new stars are being born.